So you may have wondered always why someone would use generics and prefer using generics over not using generics in special cases. I will show you an example where it's a good way to think about generics and using generics, because generics have some benefits that you don't have if you don't use them in special cases. So let's start with an example. We want to create a new class. This key value pair is its name, and you create a class, and we want the class to hold a key and a value, as the name suggests, and the key and the value should be of arbitrary type. So we say we have a key, and the key is, because of arbitrary type, we use an object as a bound, and we say key, duplicate that line using Control D. We rename that to value, and we generate some constructor and getters and setters using Alt insert combination on your keyboard. Getter and setter. So now we are finished. We have built our class. Now we want to do something with the class. Just for that case, I just generated a main method using Control J and typing in psvm and get a public static void main method. And in this method, we want to create a key value pairs. Let's say we have a key value pair 1, which contains a string as a value, and a number, let's say an int, as the value in this case. And we have a second one which takes also a string as a first as a key, and also an integer as a second part of the constructor call. After that, we want to somehow print out the result of adding the value of key value pair 1 to key value pair 2. So we can say something like key value pair 1 dot get value plus key value pair 2 dot get value. So it doesn't compile. Why doesn't it compile? Because it says, oh, plus cannot be applied to object. Okay, it doesn't the compiler doesn't look at this point here, so we could see that there are only integer values in it, but the compiler actually looks at the class definition and sees that there is just a bound saying that it's a key, that the key is of type object and the value is of type object. So in this case, the value is of type object, and there's no plus operation for objects. So what we actually need to do is to cast. So we cast them to integers. Do that for the second value too, and if you do that, everything compiles. If we run that method again, or we run it, we get the result that we expect. It's a 3, it's okay. So at some point you may refactor your method to say something like we want to have double values in it. So you can say 1 d, so everything is okay. We do that. What happens? Oh, we forgot to change the cast, because we now have double values. So for this case, we must change the casting types here to double. So that's something that's really annoying, because you didn't see it in the first place that you have to change the casts for the values. So in order to do that, we can change the cast types, everything works, but the really annoying thing is that you don't get a clue that it's something that you have to do. So at some point maybe there's more code between the two lines, or the corresponding lines where you need to change the cast. So it may always broke somehow. I think it's not refactoring safe. So what can we do to make it refactoring safe? Yes, as you might have guessed, generic types come in handy for this case. So what we can do now is we can introduce some two parameterized types here at our class. Let's say k and v, and K is the class type for the key, and V is the class type for the value. We don't provide any bounds, so K and V could be of arbitrary type, so it could be something like object, or it could be something like, I don't know, numbers, strings, lists, something else, anything of the type system that is declared in your application. What we do now is we change the types of the key and the value to these parameterized types. So it's saying something like key is of type key and value is of type V. So you have to change that at every single occurrence in our class. Somehow I just making a mistake here, so I have to put in a V here because we want not both values, both the key and the value to be of the same type. You could also use the same type if you like, but then it just limits us to use the same type for the same class type for the values as for the keys. But we don't want that in our case. We want them to be independent from each other. So now if we refactored our class, everything looks fine for now. But even if we change that here back to our initial problem case or problematic case, it doesn't do anything more. It doesn't give you a clue. But what it actually changed is a hint here, a warning that says, oh, you have an unchecked call to key value pair KV as a member of raw type key value pair. So what does it mean? You have a generic type class, or generic class in this case, generic type argument in your class, and you didn't provide any of these here, so they are just raw. They something like saying key value pair without this generic declaration is something like key value pair object, object comma object. So we like to change that in order to have type safety here. So if we do that, we can do something like string. String is a value of string is a class type of the first argument, and for the key, and we somehow want there be stored values of type double. So we put double as a second one. We put these declarations here also. So now the warning is gone. In the second case, we have the same types, and now we get a compile error. It says something like inconvertible types cannot cast Java lang double to Java lang integer. Oh, cool. So I can just remove them because these casts are not necessary anymore. And everything works. Even if I change this one here to something like, I don't know, floats, then I have to change this one here to floats. But after I changed it, everything works. Even if it's not maybe quite a good idea to add floats and double values all along. But it just works. So that's it for generics, for the basics. So we are done here. Hope to see you next time.